Yes.
Okay, perfect. I was saying that I would like to thank you, Chair, for the introduction. And also, I would like to thank the organizing committee for this kind invitation at this conference in order to present some thoughts and some very rough research activities that we are doing in the lab regarding the olive meal wastewater. And the topic of today's presentation is valorization of olive meal wastewaters in the era of circular bioeconomy. First of all, it's a very small introduction, and I will go through these slides very fast in order not to take advantage of the time. We are in a lab from the soil. We are in a lab in Soil and Water Resources Institute of the Hellenic Agricultural Organization, Demeter. We are working with bioprocesses, so different processes that we are using microorganisms in order to catalyze different compounds, and we are working mainly with waste valorization. So we have waste treatment, agro-industrial wastes that we are using microorganisms to produce high market value products, either in the form of energy carriers or in the form of other bioactive compounds. We are doing pilot testing after the lab verification, and we are working a lot with molecular techniques, metagenomics and metatranscriptomics, because as said, all these processes that we are working on are depending strictly on the effect, the efficiency, and the adaptation of different kind of microorganisms. And the last one, it's the circular bioeconomy, which is the umbrella of all our bioprocesses, because we are trying to look at a 360 approach, biorefinery approach, on how we can utilize something that it's called nowadays waste. We can call it a byproduct, in order to produce something that it's useful and to give to this residue a second life. We have ongoing collaborations with different international and national universities, and we have also a strong network with different companies that we are working on solving and developing new innovative products. So now to the presentation. About it cannot be disputed, it's without any doubt that olive oil production, it's an important sector, both economically in the EU countries. We can see that EU produces roughly 67% of the world's olive oil, and specifically for Greece, I would say that according to the last statistics, approximately 15% of the cultivation of olive trees are occurring in our country. So there is no any doubt that we have also, as a country, a strong impact on and relation with this topic. Now, what is the problem coming out from the oil processing industry? Is that we have a huge quantity of different wastes, and we talk about also wastes that are solid ones, like wood, branches, or leaves. And we have also the liquid ones, like the olive meal wastewater that are coming out from the olive extraction process. We can see in this slide that in order to understand how much waste and wastewater we are producing, we can see that out of 1 ton of olive, we can get approximately 200 to 400 kilos of solid waste and 400 to 600 kilos of wastewater if we are using a traditional system. While if we are using a three-phase system, we have approximately 500 to 600 kilos of solid waste and approximately a ton or 1.2 tons of wastewater. And if we use a two-phase process, we have 800 to 950 kilos of solid waste and also something like 100 kilos of wastewater. So we can understand that it's while producing the olive oil, we have quite a lot of waste and wastewater production. So here comes the circular bioeconomy, because circular bioeconomy, because we have to understand how we can utilize these wastes in order to valorize them, first of all, but in parallel, if we can get also some other products out of it. Circular bioeconomy comes from the movement from the egocentric to the ecocentric approach. We can see this egocentric, where is this pyramid. We are not agreeing with this pyramid, where you can see the different stratification of the species, but we have to move to a more circular concept in which all the parts of this value chain has their own preposition and each one interacts with the other. In other ways, we can see that about circular bioeconomy, that it's the goods of today the goods of today are the resources of tomorrow at yesterday's resource prices. This is something that Walter Stachel said in the past, and out of which we are trying to define what is circular bioeconomy. Actually, if you try to see in the literature and also in the EU legislation of what is circular economy, you are going to go into a vast different definitions. In order also to be on the same page, I have kept the one from the Finnish bioeconomy strategy, because I think this one, it's the one that combines everything together. So according to the Finnish bioeconomy strategy, the circular bioeconomy is an economy that relies on renewable natural resources to produce food, energy, and products. And also the bioeconomy strives to reduce our dependence on fossil natural resources, also to prevent biodiversity loss, and also to create an economic growth together with sustainable development. Schematically, we can see that the difference between the linear economy and the circular economy, we are trying to avoid this take, make, and dispose concept, and we go to make, consume, and enrich concept. And the last thing about bioeconomy, before going more deeply into the olive production, it is that through the circular bioeconomy, as I said, we have to produce some products which they have a different value proposition. And we can see in this pyramid the economic value of the different products that we can get out of a biorefinery concept. The most cheap, it's the energy, but of course it's a larger quantity of the product that we can get. And what is economically more high is the pharmaceuticals, bioactive compounds that we can use in order to implement them in the pharmaceutical or cosmeceutical industry. So in this slide, we have a canvas on circular business models. It's again like the pyramid that we have seen together, but here we can see the valorization pathways from resources to the value proposition. The outputs that we can get from the cultivation of olive trees, and also the effluents or the byproducts that we can get out from the olive mill, the olive oil extraction. So starting from the highest in volume, somewhere here we have solid waste, like the wood from the pruning. All these can go, the flowers can go for cosmetics, but most of them, of this high quantity wastes, they are going for the generation of electricity and heat. While we have also, as said, from the flower, some molecules that we can extract either from the wastewater or also from the leaves, and they can be used as antioxidants in cosmetics, or can be used also as tanning agents in ecological leather processing, or also some other bioactive ingredients for medical compounds. The water, and we will see that in one example, they can be purified, they can generate also some kind of energy, but mainly they can be used again for the irrigation of the olive trees. So going now to show you two examples. The first example is something that we are using in the lab. We are developing in the lab, not only with olive wastewater, but also with other types of agro-industrial wastes. But it is something relevant. It's the production of energy, and I will tell you what. But to couple it with something else, because I said the energy is the one of the product, but it doesn't have so much profitability in some cases. So the first one is the utilization of olive mill wastewater in a combination of with a combination of anaerobic digestion. So I don't know how many of you are aware of the anaerobic digestion and the biogas production. Here we can see a very rough schematic process. So we have a biogas digester which is fed with different kinds of agro-industrial wastes, out of which it can be also the olive mill wastewater. The wastewater are remaining inside the anaerobic tank for a certain amount of days, depending on the temperature of the operational temperature, and then we can get biogas. Biogas is actually a gas mixture. It contains approximately 50 to 75, I would say mostly 50 to 60% methane. The rest is carbon dioxide, while it has also some impurities like nitrogen, hydrogen sulfide that it should be removed. But we have also some impurities in this gas mixture. What we can do with this biogas is to burn it in a combined heat and power unit, as we can see here. And from the 100%, let's say, biogas, we can produce approximately 35 to 40% out of this proportion goes to electrical energy, can be sold to the national electrical grid, while another 45 to 50% it is heat. It can be used to heat again the anaerobic digester, or it can be used for heating other agricultural structures that are around the biogas plant, since we are talking about rural areas. And we have 15% approximately losses because of the capacity of the CHP. Now, if we are going to do something like that with olive meal wastewater, it will be certain no. Of course, we know that olive meal wastewater, they have a seasonality. They are from November up to, let's say, February. So we cannot run an anaerobic digester only for this period. We would like to have something all the year. So what it's the most easiest thing to do is to combine it with other agri-industrial wastes. And olive meal wastewater, they have some particularities in their chemical composition. They have a very high COD and a lot of carbon inside, but they are very poor in nitrogen. On the other hand, we have a vast amount of other, especially livestock resources, like pig manure, that they have a lot of ammonia inside, so they have a lot of nitrogen inside, which this ammonia causes a toxicity to the microorganisms. On the other hand, by combining these two wastes, so we have not only a monodigestion, but like a co-digestion process, it improves the overall anaerobic digestibility of these substrates. Especially as we can see in these slides, by doing this co-digestion, we improve the digestibility, we improve the energy yield, we have more methane, we improve the CN ratio, and this is something very peculiar and very specifically for the olive meal wastewater. Also, we can alleviate toxicity issues. We know that olive meal wastewater, they have a lot of long-chain fatty acids. Again, it's toxic. It can cause toxicity to the microbes. So by combining it with another waste, we can have a benefit out of it. We can improve the economic viability of the plant, of the biogas plant, and also we can address the seasonality of some wastes. But as I said, this is something that creates energy, but energy in some cases is not so much appreciated, I mean, economically compared to other processes. So what we are trying to do here is to utilize this waste in order to produce methane. And I will couple it with something else, and I will tell you how this is actually afterwards overlapping and integrating. We have another problem nowadays, that it's the lack of food, and especially proteins. We know that approximately every person per day has to have 100 grams of edible protein, and trying to source other ways of producing protein. Actually, nowadays we are working on proteins that are come from plants. Since we have also this lack of agricultural soils, we have to try to find out other alternative ways to produce this protein. And one of them is this microbial protein. And I will tell you now how these two concepts, they can be integrated together. In this slide, we can see the conventional biogas production. So we have olive meal wastewater that they are going to an anaerobic digester. They are fermented. We are producing biogas. Biogas goes to the CHP. It is burnt. We are producing electricity. We are producing heat. And also, it could be possible that after cleaning and upgrading, we can have biomethane, which is an alternative to natural gas. So we can have fuels, and it can be used for home cooking. And also the leftovers from the digester, it's a digestate. It is rich in inorganic compounds. It can be used after dewatering and pasteurization as a biofertilizer. So this is the conventional way. And actually here we can use, as said, a co-digestion process. So we have different other substances to work together for the biogas. Now, what we are working on is to have again the biogas, but on the other hand, utilize the methane out of the biogas and utilize the nutrients from the digestate in order to cultivate some specific microorganisms like Methanococcus capsulatus, which while they are fermenting this methane, because they need methane and some nutrients to metabolize, they are producing in their cells, they are accumulating protein. So out of this process, instead of producing only energy, we are producing partially energy, but mainly we are using the methane in order to produce something that it can afterwards go as an animal feed, or it can be, and this is actually now we are trying to investigate because there is a problem with the legislation to go also to human feed. But definitely for animal feed, it can go, or for fish feed. The second example is another one that I am borrowing it from another paper. We are not working on this concept because it contains also this.
Kougias, please try to conclude. We went over time.
It's my last slide.
Okay.
Sorry for. And in this concept, we have, let's say, the olive oil production, and after the olive oil production, we have the organic fraction of the wastes and also the wastewater. After the drying process, we can get out the water. The water needs some specific pretreatment, especially for the adjustment of the pH, but this water can be used again for the olive tree irrigation. But the dried matter, it can go for pyrolysis. The pyrolysis, if it is slow, it can produce gas, and the gas can be used also for heating the process of drying. We have biochar, and the biochar, it can be used again to be incorporated into the soil, a soil amender for improving the oil production, the olive tree production. And also we have some bio-oils, and the bio-oils, again, it can be refined and it can be used as a fuel in order to be used for the processes of olive oil that we need some extra heat. So this is another concept of different circular economy in which we can use waste out of olive oil production in order to produce multiple products. This is my presentation till now. I would like to hear if you have any question, and if you would like to hear more about what we are doing in the lab. I am showing you here our social media, and by this I would like to thank you for the kind invitation and your attention.
Thank you, Dr. Kougias, for this very interesting presentation. And